unicast source here, and we want to have everybody that's at B, D, F, G, E, C, all these sites, be able to participate at the application level in group communication, we have to get the network supported. Now, this is the most inefficient way to get the packets there. Okay, we will have head-end replication, and this link is going to be a problem. So, of course, a way to solve it is if you had multicast as part of the network, you could actually send one packet in, and it gets multicast replicated at these places at the core, and then it hits these unicast-only clouds, where in which case then they would have to be unicasted to the edges. That's a little bit more efficient. In fact, it's way more efficient on the head end. Okay. Well, if you look at it, if you're doing this over Lisp, these are just basically re-encapsulating tunnel routers. Okay, so let's say we deploy these re-encapsulating tunnel routers, RTRs, in A, rather than encapsulating and sending it to the green boxes, it encapsulates in unicast and sends it there. And of course, then it will replicate to those two RLOCs, and likewise replicates it. So we can do this in a scalable way. We can do unicast encapsulation without head-end problems by deploying these RTRs in the network. And the advantage is if we put them in the network is that service providers can participate in this. A lot of times service providers worry about overlays because they look like they're just moving bits and they're adding no value. By putting RTRs in the middle of the network, they can add value. You can add service chaining to this capability as well. You could actually inspect packets, you can add security. There's all kinds of things service providers could help in aiding the delivery. So what LispRE is it introduces a multi-level RTR hierarchy. RTRs and levels are registered as RLOCs in the mapping database. And they'll register it for a prefix, an S prefix and a G prefix. Because an S prefix may be an entire site where there's lots of sources. Protocol signaling using PIM or Lisp is used by the ETRs to join level N routers. And then the level N routers will join level N-1 routers. And then the level 0 RTRs will join the ITRs. This is an example of how it can work. So let's say we have these ETRs that are sitting at various sites. These are all individual sites, and those receivers are sitting out there. There's no receivers at the top ETR, so it won't do anything. What we want to do is we want the white arrows you see is the join state. It's where the join signaling goes. And therefore, the data packets will flow in the opposite direction of the lines. But what the ETRs have to know is they have to join to some part of the infrastructure. And so what they'll do is when they get an IGMP report, if there's a directly connected receiver, or a PIM join if it's multi-hop, what will it do? It will do a longest match lookup on that S, G that's being joined into the mapping database. The mapping database will have this S prefix, G, and what we'll show is the various levels. We're showing that 22, 23, and 24, or 21 through 24 are layer 2 routers, layer 1 routers are 11 and 12, and layer 0 is 1. So what ETRs will do when they receive this entry is they'll say, I'll join to one of these 4 guys. Okay, what I'm going to do is I'm not going to join to this guy because he has priority 255, but I can load split my S, G flows, my join flows over these places. So, you know, those 2 ETRs choose this one, that ETR chooses 23, and the bottom 2 choose 24. Now, when those RTRs at level 2 get it, they will do the same lookup, get the same entry, and since they're level 2, they'll join to level 1, and so forth and so on. If there was only level 1 routers here, it would look like the original picture where the ETRs joined directly to the ITR. But if this was going to be at Deutsche Telekom and BT and AT&T, it could be that way. Now what happens is those 3 service providers would coordinate this service. They would either use an SDN controller or pick one of the devices in the network to register this state that they all agree on, and then everybody can use this state. This is really fresh work. We started in Atlanta IETF, and the guys at UPC Barcelona, Alberto's here, his colleagues, are helping out on this, is helping us figure out how to do optimization algorithms, and if an SDN controller could help in the aiding of this programming. Okay, we could use the explicit